everybody, today our group will guide you on how to perform matrix addition, subtraction, multiplication, matrix inversion, solving a system of linear equations, and finding the equilibrium point of supply and demand. For example, we have two matrices A and B here. Based on these two matrices, we will perform matrix addition. It will be carried out in the following steps. First, input matrix A into a set of intersection cells and matrix A into another one with the same sign. Then, try the equal B equal sign. Use the mouse to highlight the first matrix to be added. Press the plus sign on your keyboard and highlight the second matrix. Select the range where you want the result and press Ctrl+Shift+Enter at the same time. And the result will appear. Compare the result with the one we have calculated manually. Next to matrix subtraction. The procedure for subtracting two matrices is similar to addition. Start by selecting any cell, typing the equal sign, and using the mouse to select the first matrix to subtract. Press the minus sign on the keyboard and highlight the second matrix. Press Ctrl+Shift+Enter at the same time, and the result will show up. Compare with the result we have calculated manually. Next, to calculate matrix scalar multiplications. For scalar multiplication, the steps are almost identical. Select a cell, try the equal sign, and highlight the matrix you want to multiply. Keep in mind that there is no in symbol for multiplication on the keyboard, so use Shift and 8 to input the asterisk. Then select the cell containing the scalar value to multiply with, and press Ctrl+Shift+Enter at the same time. Compare the result we have calculated manually. Next, to calculate matrix multiplication. To multiply two matrices, you need to use the MMLT function in the Excel. First, select any cell, try the equal sign, and enter MMULT function. Next, highlight the first matrix, try a comma, and then highlight the second matrix, close the parentheses, and hit Ctrl+Shift+Enter at the same time. If a right sign appears, it means the cell size is subtraction, but the result is still correct. Simply adjust the column wide to display the outcome properly. Compare with the result we have calculated manually. Now, let's calculate the transpose of matrix using the transpose function. Select an empty cell, try the equal sign, and input the transpose function. TRANSPOSE function. Then highlight the matrix to transpose and press Ctrl+Shift+Enter at the same time. Compare with the result we have calculated manually. Now, let's find the determinant of square matrix. We use the modicum function. First, select an empty cell, try the equal sign, and then enter MDETERM function. Highlight the matrix you want to evaluate, and press Ctrl+Shift+Enter at the same time. The result will show up. Compare with the result we have calculated manually. Next, we will find the inverse of a square matrix using the minverse function. Select any cell, try the equal sign, and enter minverse function, MINVERSE function. Highlight the matrix, try parentheses, and press Ctrl+Shift+Enter at the same time to compute the result. Compare with the result we have calculated manually. Finally, let's solve a system of linear equations. Consider a set of expressions with polynomials as shown below. The coefficients of the corresponding equation have been placed in the cells. To solve the system, I will use and minverse function to inverse the matrix. Step to solve a system of linear equation in Excel. First, enter the coefficient matrix A and the constant matrix P in Excel. Use the inverse function to find the inverse of matrix A. This is the result. Press multiply the inverse matrix by the constant matrix using MMULT function. Press Ctrl+Shift Enter and execute as an array formula. The solution for each E, Z, and T will be displayed.
Next, we will discuss how to find the equilibrium point of supply and demand. Suppose the market consists of 4 products, goods 1, 2, 3, and 4, with the following supply and demand functions. To find the equilibrium point of supply and demand, we have some following steps. At the equilibrium point, we have QS1 equal QD1, QS2 equal QD2, QS3 equal QD3, QS4 equal QD4. We will substitute the supply and demand function into each QS and QD, then convert them into a system of equations. From the final system of equations in this slide, we will write it in the formula of matrix as follows. First, we will apply Cramer's rule to create matrices A1, A2, A3, and A4 by replacing the constant terms of the equation into columns 1, 2, 3, and 4. Then we calculate the determinant of matrix A, A1, A2, A3, and A4 using the following function MDETERMAER. We have the following variable calculation formula, where AG is the matrix content from matrix A by replacing column G with the constant terms of the equations. By applying the formula, we'll find the solution to the system by dividing the determinant of AG by the determinant of the A. Finally, we will discuss how to show the input-output models. This is our example. Consider an input-output model with 4 sectors: agriculture, manufacturing, power and oil. Assume that the input requirements are given by the following table. Given that the vector of demand B equal 500, 600, 7 and 1500, 5 and 300, find the vector of final output X in the economy. This the following step to calculate input-output model. Now, let's practice. To calculate it, we have the equation. Start. To find the I minus A matrix, we subtract the identity matrix I from technical coefficient matrix A. Next, we find the inverse matrix of this using the inverse function. Do it similarly. Finally, by applying the formula above, we use the mute function to multiply the total cost coefficient matrix with the final demand matrix. Press Ctrl Shift Enter to get the result. The result obtained is the total demand X, which we need to find. Thank you for your writing. Our team names Night is Light. Scan this QR code to reset the compiled documents